Imagine waking up tomorrow to a world utterly transformed by silence. Every city, once a vibrant chorus of human activity, has fallen quiet. The endless hum of traffic, the distant wail of sirens, the murmur of countless conversations, all gone. You stand alone, and in this profound stillness, you discover that every other person on Earth has simply vanished. There are no bustling streets, no crowded markets, no lights shimmering in distant windows. The planet, for the first time in millennia, is devoid of the overwhelming presence that has defined it for so long. The great monuments of our civilization stand as empty shells, their purpose lost in a single inexplicable moment. Without us, the world we built would begin to unravel. The intricate systems that sustain modern life would falter and fail within hours. Power grids would collapse, plunging continents into darkness. Automated systems would cease their operations, and the relentless flow of information that connects our global society would come to a halt. The roads, once arteries of commerce and travel, would become desolate, forgotten paths. The towering skyscrapers, symbols of our ambition and ingenuity, would stand as silent, hollow giants against the sky. Our dominion over the planet, once so absolute, would be revealed as a fragile and temporary state of being. The Earth, however, would not remain still. Nature, patient and persistent, would begin its slow and steady process of reclamation. Weeds would crack through asphalt, their determined tendrils seeking sunlight. Vines would snake their way up the sides of buildings, softening the harsh lines of our architecture with a blanket of green. Animals, no longer constrained by our fences and highways, would venture back into lands they once roamed freely. Forests would gradually encroach upon suburbs, and rivers, freed from their concrete channels, would carve new paths across the landscape. Our world, our creation, would slowly be erased. Within a few thousand years, the evidence of our existence would become a geological whisper. Almost every trace of humanity would disappear, weathered by wind and rain, buried by soil and sand. The grand structures we believed were permanent would crumble into dust, their materials reabsorbed into the earth from which they came. Only the most durable of our creations might survive as strange, inexplicable anomalies for a future non-human observer to ponder. Our story, etched in steel, concrete, and digital code, would fade until it was little more than a forgotten layer in the planet's deep history, a brief, bright flash in the immense darkness of time. Yet the story of humanity stretches back far beyond the cities we built or the histories we wrote down. It is a narrative that predates kings and queens, empires and civilizations, and even the first spoken words that gave rise to language. It is a saga of survival, a relentless struggle against a world that was often hostile and unforgiving. Our ancestors did not live in a world of comfort and convenience. They navigated a landscape filled with giant predators, unpredictable climates, and fierce competition for the scarce resources needed to stay alive. Their world was one of immediate dangers and constant challenges, where each day was a victory. For millions of years, the slow, deliberate hand of evolution shaped one species of our lineage after another. It was a process of trial and error on a planetary scale, a grand experiment with countless variations. Most of these early attempts at what would become human disappeared forever, their lines ending in extinction. They were evolutionary dead ends, their stories lost to time, their bones scattered and buried without a record. They were crucial steps in the journey, but their paths did not lead to the present. They are the forgotten chapters in our epic, the silent witnesses to a long and arduous climb. Only one lineage, against all odds, managed to endure. It was a chain of survival forged over eons, linking one generation to the next through a shared instinct to persist. This single, unbroken thread of ancestry navigated every catastrophe, adapted to every new environment, and overcame every challenge thrown its way. From the deep forests to the open savannas, from the pressures of the Ice Age to the warmth of interglacial periods, this line held on. It was a story not of inevitable triumph, but of incredible resilience, a testament to the power of small advantages accumulating over immense stretches of time. This surviving lineage eventually gave rise to a creature unlike any other that had walked the earth. It was a being with a mind capable of looking back at the long, winding path it had traveled. It developed a unique and powerful curiosity, a desire to understand not just how to survive, but why it was here at all. This creature, a latecomer to the planetary stage, began to look at the stars, at the fossils in the ground, and at its own reflection, and ask the greatest question of all: where did we come from? This question marks the true beginning of our quest for self-knowledge. This is the epic story of human evolution, a journey from stardust to modern humanity, from the rise and fall of dinosaurs to tiny mammals surviving in the shadows, and finally, the dawn of humans. This is how we came to be. Our story begins not on Earth, but in the vast emptiness of space with the death of ancient stars, their explosive ends scattered stardust, carbon, iron, calcium across the cosmos. We are quite literally made of stardust. From this cosmic debris, Earth was born, setting the stage for the dawn of life. Somewhere within these warm, shallow, ancient seas, the most extraordinary event in our planet's history took place. The simple chemical ingredients present in the water, carbon, hydrogen, nitrogen, oxygen, began to combine. Energized by lightning, underwater volcanic vents, and the unfiltered ultraviolet radiation from the young sun, these simple molecules formed more complex structures. They became amino acids, the building blocks of proteins. They became nucleotides, the components of DNA and RNA. Over countless trials and errors in some sheltered primordial soup, a truly remarkable molecule came into being, one that could make copies of itself. Life had begun. Exactly how this transition from non-living chemistry to living biology occurred remains one of the greatest unsolved mysteries in science. Perhaps it happened in sunlit tidal pools, or in the dark, superheated water gushing from hydrothermal vents on the ocean floor. Whatever the location, the emergence of the first self-replicating organisms marked a fundamental turning point for the planet. These earliest life forms were incredibly simple, nothing more than microscopic single-celled organisms, likely similar to modern bacteria. They were the pioneers of existence, the ancestors of every living thing that would ever follow, from the smallest microbe to the largest whale. For nearly 3 billion years, an almost incomprehensible stretch of time, life remained incredibly simple. The world belonged to these tiny microbes. They were the sole inhabitants of the planet, silently floating in the oceans, forming vast mats of single-celled colonies. Yet, despite their simplicity, these organisms were performing a task of world-altering significance. One group, known as cyanobacteria, evolved a revolutionary new process, photosynthesis. They learned to harness the energy of sunlight to create food, and in doing so, they released a waste product. That waste product was oxygen. It was a poison to most other life forms at the time. Slowly, inexorably, these tiny bacteria began to transform Earth's atmosphere. For hundreds of millions of years, the oxygen they produced was absorbed by iron in the oceans, which rusted and settled on the seafloor, forming massive banded iron formations. But eventually, the oceans could absorb no more. Oxygen began to build up in the water and then poured into the atmosphere. This great oxidation event triggered a mass extinction of organisms that could not tolerate oxygen. But for the survivors, it opened up a new world of energetic possibilities. This new oxygen-rich atmosphere would be the fuel for larger, more complex forms of life to evolve. After billions of years of microbial dominance, evolution suddenly shifted into high gear. Around 540 million years ago, in a geological blink of an eye, the planet's oceans burst forth with a bewildering array of complex multicellular life. This event was so dramatic, so sudden, that scientists call it the Cambrian explosion. It was as if life, having spent eons tinkering in its microscopic workshop, finally threw the doors open to reveal its creations. The quiet, simple world of the past was gone forever, replaced by a vibrant, teeming ecosystem filled with creatures of astonishing diversity and strangeness. The age of visible life had arrived. This biological Big Bang saw the emergence of almost all the major animal body plans or phyla that exist today. Some creatures developed hard external skeletons, providing both protection and a framework for muscles to attach to. The famous trilobites, with their segmented bodies and complex eyes, scuttled across the seafloor. Others evolved shells for defense, like the first mollusks. Predation became a major evolutionary driver for the first time. The hunt was on. Anomalocaris, a giant for its time, patrolled the waters with grasping appendages and a circular mouth full of sharp plates, becoming Earth's first known apex predator. This explosion of life was driven by a perfect storm of environmental factors. The rising oxygen levels provided the energy needed to power larger, more active bodies. The warming climate after a global ice age created more hospitable habitats. The chemistry of the oceans had changed, providing the minerals needed to build shells and skeletons. Evolution began to experiment wildly. Some creatures, like the five-eyed opabinia with its frontal nozzle, or the spiny hallucigenia that walked on stilts, were so bizarre they seemed to belong to an alien world. They were early evolutionary experiments, most of which would eventually vanish. The Cambrian explosion was not just a riot of new forms, it was a revolution in biological engineering. The evolution of eyes, for example, transformed the dynamics of survival. For the first time, animals could see each other, leading to a new and intense arms race between predator and prey. Senses became sharper, bodies became faster, and behaviors became more complex. Buried within this incredible burst of evolutionary creativity was a small, unassuming creature, perhaps no longer than a finger. It had a primitive nerve cord running down its back. It was one of the first chordates, and its descendants would one day make history. After the Cambrian explosion, fish emerged as the dominant force in the oceans, evolving jaws and fins that made them formidable predators. Some fish developed primitive lungs and strong lobe-like fins, setting the stage for the first steps onto land. Over millions of years, these fins became limbs, leading to creatures like Tiktaalik, part fish, part landwalker, who could haul themselves onto mudflats. The evolution of the amniotic egg freed reptiles from water, allowing them to conquer the land and become its new rulers. Dinosaurs appeared around 230 million years ago, dominating Earth for 160 million years with astonishing diversity, from tiny hunters to colossal sauropods and fierce predators like T-Rex. While dinosaurs ruled, small nocturnal mammals survived in the shadows, developing traits like warm-bloodedness, hair, and larger brains. These mammals nursed their young and thrived in the margins, waiting for their chance. Their moment would come after the dinosaurs' reign ended. "66 million years ago, a massive asteroid struck Earth, unleashing devastation, firestorms, tsunamis, and a global winter that wiped out 75% of all species, including nearly all dinosaurs. The food chain collapsed, and the world's ecosystems unraveled. Yet deep underground, small mammals survived the apocalypse. When the skies cleared, they emerged into a world ready for new beginnings. The age of mammals had begun. With dinosaurs gone, mammals rapidly diversified. Some returned to the seas, others roamed grasslands, and a few took to the trees. Life in the canopy drove the evolution of primates, with forward-facing eyes, grasping hands, and growing brains. Early primates, like Purgatorius, thrived in this new world, their adaptations paving the way for future evolution. These were the first steps on the branch that would eventually lead to us. Over millions of years, primates flourished, splitting into lemurs, monkeys, and, in Africa's rainforests, the first apes. Apes like Proconsul lost their tails and developed powerful arms for swinging through trees, setting the stage for upright movement. As forests shrank and savannas spread, some apes adapted to new environments, while others ventured onto open ground. This shift would soon spark the beginning of our own evolutionary journey. As Africa's forests fragmented, one group of apes split into two lineages, one leading to chimpanzees and bonobos, the other to us. Humans and chimps share a common ancestor, but each evolved along separate paths. Early hominins like Sahelanthropus chidensis show signs of upright posture, marking the dawn of our lineage. The search for our earliest ancestors continues, but the journey toward humanity had begun. The first hints of upright posture appear in Sahelanthropus, but with Australopithecus, bipedalism becomes clear. A single femur tells a powerful story. Australopithecus regularly walked on two legs. Walking upright freed the hands, letting our ancestors carry food, tools, or infants. Standing tall helped them stay cool under the African sun. Over generations, these small changes led to a world-changing transformation. Scientists once thought our ancestors first walked upright on open savannas, but the discovery of Ardi in Ethiopia changed everything. Ardi lived in woodlands, not open plains, showing bipedalism evolved among trees. She was both a climber and a walker, neither fully ape nor human, but beautifully in between. Around 4 million years ago, the Australopithecines, southern apes, emerged in East Africa, adapting to life on the ground. Their bodies evolved for upright walking, with longer legs and stable ankles. In 1974, a remarkable discovery changed everything: the partial skeleton of Lucy, offering a face to our distant past. Lucy, Australopithecus afarensis, revealed our ancestors walked upright long before their brains grew large. At Laetoli, ancient footprints show these early hominids walked just like us, their steps frozen in volcanic ash nearly 4 million years ago. Standing beside those prints, we feel a powerful connection to our deep past. Life for the Australopithecines was a daily exercise in survival. Living in small family groups, they relied on social bonds and learned from elders. Then a breakthrough, striking two stones together, created sharp flakes, the first tools. This invention, the older one tool industry, marks the dawn of human technology and changed our evolution forever. The emergence of stone tools marks the rise of Homo habilis, the handy human, around 2.4 million years ago in East Africa. With a larger brain and smaller teeth than its ancestors, Homo habilis used tools to access meat and marrow, fueling brain growth. Their dexterous hands and clever scavenging made them true survivalists, passing on new skills to the next generation. Around 1.9 million years ago, Homo erectus emerged in Africa, an upright human with a modern body built for endurance. They were the first to leave Africa, spreading across continents and adapting to new environments. With intelligence, cooperation, and fire, Homo erectus changed our story forever. Before modern humans, Europe was home to the Neanderthals, remarkable, complex, and resilient. Modern science reveals they were not brutish, but intelligent and adaptable. Stocky and strong, they survived ice ages and hunted giant beasts. Master toolmakers, they crafted advanced weapons and cared for each other. Neanderthals, different but truly human. They were family. For years, we thought our ancestors only met Neanderthals after leaving Africa, but a tiny bone from Denisova Cave in Siberia revealed a new, mysterious human lineage, the Denisovans. Their DNA showed they were distinct from both Neanderthals and us, spreading across Asia and even interbreeding with modern humans. Today, traces of Denisovan DNA live on, especially in people from Melanesia and Papua New Guinea. The human family tree is far bushier than we once thought. On Flores Island, scientists found Homo floresiensis, tiny tool-using humans nicknamed the Hobbit. In South Africa, Homo naledi was discovered deep in a cave, with small brains but possible ritual behavior. These finds remind us that our world was once home to many different kinds of humans, each with their own mysteries. While Neanderthals ruled Europe, our story began in Africa. Around 300,000 years ago, Homo sapiens, the wise human, appeared distinct in body and mind. Our greatest advantage was a cognitive revolution, symbolic thought, language, and creativity. Armed with this, Homo sapiens was ready to leave Africa and change the world. For over 200,000 years, Homo sapiens lived in Africa. Then, around 70,000 years ago, we began a slow expansion across the globe. Driven by curiosity and change, our ancestors spread into new lands, meeting Neanderthals and Denisovans, and interbreeding with them. Within a short time, humans reached every continent, adapting to deserts, tundras, rainforests, and mountains. Our greatest tool was cooperation. Sharing knowledge and resources, we became the last human species standing. For most of our history, humans lived as hunter-gatherers, small, mobile groups deeply connected to nature, thriving on knowledge, cooperation, and a varied diet. Their lives were not constant struggle, but balanced with leisure, storytelling, and community. Then, about 12,000 years ago, some began to farm, forever changing the course of humanity. After the Ice Age, warmer climates allowed wild grains to flourish in fertile regions. Early humans settled, harvesting and planting seeds, sparking the agricultural revolution. They also domesticated animals, creating reliable sources of food. Surplus food led to larger villages, new jobs, and private property. But this new life brought health problems and inequality. There was no turning back. Agriculture led to more food, more people, and the rise of villages along fertile rivers. These villages grew into cities like Uruk, bustling with trade, religion, and new social hierarchies. To manage complex societies, people invented writing, first for accounting, then for laws and history, forever changing how knowledge was stored and shared. Civilizations rose, empires expanded, and trade routes like the Silk Road connected the world, accelerating history. The Industrial Revolution transformed societies and the planet itself. Now, our technology can alter the climate and edit life's code. The future is unwritten. Our story is only just beginning. Look at your hands. Wiggle your fingers. Clench your fist. Within them lies a story written over millions of years, a legacy of survival, adaptation, and curiosity. Every bone and muscle connects us to ancestors who shaped tools, painted dreams on cave walls, and gazed at the stars. We are the improbable inheritors of this epic saga, still writing the story written in our bones. The story of humanity is our shared inheritance, a journey from humble beginnings to shaping the world and our future. Now, we stand at a crossroads, holding the pen to write the next chapter. The future of humanity is not in our stars, but in our hands.